Hello, welcome. I'm back. I'm glad to be back. Sorry I missed last Thursday's class. It sounded like it went really well though, so I don't know if he's still here, but thanks to Ryan for filling in for me, and hopefully you enjoyed it. A couple logistical things before we get started. This is the last week of Unit 1, so that's kind of exciting. We've come a very long way. Still got a long ways to go, but we have come a very long way. Last class of Unit 1 is going to be on Thursday, and then we get to take a little break. There's no class next week. However, we are going to have study sessions next week instead, so not mandatory. You're not required to be here, but if you want to come in and get some help finishing up the last few assignments before Unit 2 starts, we will be here Monday and Thursday next week from 5:30 until question mark. I don't like to guarantee that we'll be here until 8:30 because it depends on how many of you show up. So if a whole bunch of people show up, then I'm happy to stay here till 8:30 helping people out. If 2 people show up and I help them and then they leave, then I'm going to leave. I'm going to go home. So if you want to get some help next week, please come around 5:30. And yeah, if you show up at 8 o'clock and nobody's here, don't be surprised. That just means that we finished up and we went home. There'll be some TAs here. I'll be at least one of the days. I'm not sure which one yet, but I'll be here at least Monday or Thursday. TAs will be here. And then you are expected, this is a hard deadline, you are expected to have all of the stuff from Unit 1 finished before progressing on to Unit 2. So if you need some help getting those last few assignments finished up, these study sessions are kind of your last chance to come in and get that assistance. We'll still be available on Slack, and of course we're still in class this week as well, so please be sure to take advantage of those resources. But yes, you are expected to complete all of the Unit 1 assignments before moving on to Unit 2. I think that's all I had for you. Are there any questions about the end of Unit 1 / start of Unit 2 stuff? Yes?
Sorry if you already answered this, but is there a way for us to sort of get to work on Unit 2 during that time as well?
So Unit 2 will be available as soon as Ryan posts it. I don't know what his timeline is. I think he's around, so I can try to ask him about that today and see where things are in that regard. I don't have any problem with you working ahead if that's what you want to do. But I'll need to get with Ryan and see what his plans are for distributing that material. Any other questions? Alrighty. Excuse me. So today's a big day, actually. I have been looking forward to this day since the very first day you walked in and started learning how to code. We're doing objects today. It's a fantastic day. Everything that we have done in this class up until this point has been to prepare you for this day, which is not meant to scare you or intimidate you. It's just true. It's just a fact. Objects are such a critical piece of programming these days, so I'm very excited to get to work on them today with you guys. All right, let's do some review questions, and then we're going to make at least one object in class today. Ooh, okay. So what are the 2 main features of an object? If you look at an object, the stuff in an object is going to fall into one of 2 basic categories. What are those categories? Methods, that's one, yeah. Attributes, right? So I've got the attributes and I've got the methods, the behaviors of an object. Those are the 2 main categories. If you're trying to put something into an object and it can't fit into one of those 2 categories, well, it doesn't belong in that object. Then probably it's something else. I don't know what it is. It's something else. It's not part of the object. What is this init, underscore, underscore, init, underscore, underscore? What is that about? There's a name for it. It's the constructor. It's the constructor. So what the heck is a constructor? Yeah.
So like every time you create a new instance of an object, the constructor is sort of like responsible for setting all of the default attributes
Yeah.
the programmer chooses.
Yeah, you nailed it. and I like the terminology that you use there as well. The constructor is responsible for creating a new instance of this object. So if I want to make another instance of this object, I have to call the constructor. It's how we bring things into the world in our code, is by calling the constructor. We've actually used constructors before. Let's see, I'm trying to think of some examples of when we've done that. I mean, multiple examples that we've seen, like when we created pixels, we called a constructor. When we created turtles, we called a constructor. So we've actually seen constructors at work. And the other point that you mentioned is good too. The constructor has one job. There's literally only one thing that I care about the constructor doing, which is making sure that all of my attributes, all of my instance variables, have some sort of value set to them. That is the role of the constructor. I don't want any of the class variables, right? There's like 100 different things that we call those variables. Fields, instance variables, class variables, right? Attributes, they all mean the same thing. I don't want any of those to be left unset when that constructor is finished. The constructor's job is to make sure that every single one of those class variables has a value. Can I have more than one constructor? What do we think? Yeah, we can. It is certainly possible to have more than one constructor, which is interesting. Maybe we'll see an example of that a little bit later on today. A lot of times I just need one. It's not necessary to have more than one, but certainly possible in situations where that might come in handy. What is self? What is self? A reference to the current instance of this object. It's a little mind-bending at first. It takes a little bit of getting used to wrap your head around this concept. But think about it this way. We are all people, right? So we could conceive of a person class. That person class would have attributes like name, like your birth date, maybe your address or something like that, right? And so I can look at all of you and recognize that you are in fact people. But if I want to do something myself, right, I have a reference to myself. I have something that is inward facing that I can use to think about myself. And that's useful because then you all also have that same reference to yourselves pointing inward. And so we can write code then that is geared towards acting on your inner selves and then simply change which objects we are referring to throughout this point of our code and have them repeat that behavior on themselves, which I know is probably, I might be making the situation more confusing rather than less confusing. What self allows us to do is write our code in such a way that I don't need to know what person I'm talking about, right? I don't need to know what person I'm talking about. If I want to get the name of this object, I can say self.name. And it will give me the name of that person, whoever that person may be. It actually comes into play with this next question. What is the difference between a class and an instance? We've already used this word instance before, right? Somebody used it a couple of questions ago in their answer. What's the difference between a class and an instance? In the back? Like in the way back? All right, so I like that first sentence. An object is an instance of a class. So the class is the template that all objects follow, right? The class is a template. I use that template to make specific instances. So when I'm writing a class, I actually don't know what instances I'm going to have, right? If I use the person example, I can write a person class, but as I'm writing that class, I don't know what kinds of people are going to be created. I have no idea. That's going to happen in the future, right? But I'm writing a class that needs to accommodate those instances that are eventually going to be created, whatever they may happen to be. So the class is very generic. It's very general. It's a template. I think of a class as like a blank form. Here are the blank spots on a form that you need to fill out in order to create one of these things. That's what the constructor does for us, right? And then once I've done that, once I've created that instance, I have behaviors that I can call that will modify those values on the form or do other kinds of actions based on that instance. And so I kind of already spoiled the answer to this next question. How do I create a new instance? Again, it's an important concept. How do I create a new instance? Call the constructor. Call the constructor. Constructor creates a new instance. A new instance. What is this underscore str business? What's that about? It's a string representation of the object. That's exactly right, yeah. So why is that useful? Why are we even talking about it? We can specify what we want that string representation to look like. So the typical process is probably something like this. I've created my object. I think I've got it in pretty good shape. And then I look at the attributes that it has and decide, all right, of the attributes that are listed here, which ones are important for me to know if I was going to include them in a string representation of this. Or in other words, if I displayed this object on the screen, what are the attributes that I would want to see? Because you may want to see all of them, right? Or you might just want to see some small set of those attributes. But you get to decide. When you, I like the word you use, override. When you override this, you get to decide what that looks like. If I don't override this, what happens? Does anybody know? It gives you the memory address of the object, which is maybe a little bit useful, but probably not very useful at all. So if we want something that it's actually meaningful about the object, we need to override this method and then specify what attributes we want to be given to us from this particular object. We're going to do that today, hopefully, in the walkthrough. What questions do you have? Anybody have any questions? Yeah, what's up? Oh, so the question is asking about the other method. What is it? REPR, I think, or something like that. There is a difference between the two. I personally prefer STR, but I have to admit that the only reason that I say that is because that's just what I've been using ever since I started programming in Python. I'm actually not sure if there is a meaningful difference between those two or not. Let's see. Let's see what it has to say. Strings used for creating output for end user, while REPR is used for debugging and development. I don't know if I necessarily agree with that statement, but they are allowed to have their opinion. What is the difference? Goal is to be unambiguous. Goal is to be readable. That seems a little arbitrary, but yeah, interesting. Yeah, I always use this one. Whoops, I didn't know that was a link. I always use str. It's a good question though. Any other questions about this stuff? I've got another set of review slides before I walk through. Any other questions? Any other questions? Okay. What's the difference between object-oriented programming and procedural programming? Oh man, how much time do we have? This is a deep question. I mean, objects, sure, but procedural programming can still actually have this concept of complex objects as well. It's more of how I approach the program. Yeah. Mm-hmm. Yeah, so free floating functions, yeah, that's a good description of procedural programming. There aren't necessarily objects with procedural programming. We've been doing procedural programming in this class a fair amount. If I open up Python and I just start creating some functions and there's no classes, there's no objects, That's procedural programming. Now we can actually still use objects as part of our procedural programming, right? When we used turtle objects, we were using objects, but it was very much a procedural program because all we were really writing were functions that used those objects. We weren't creating objects of our own necessarily. True object-oriented programming wants the main behaviors, wants the main actions to be part of the objects themselves. And so we don't actually call them functions anymore at that point, right? We have a separate distinction. What do we call them instead? Methods. So the difference between a function and a method is whether it's in a class or not. If it's in a class, it's a method. If it's in a function, or if it's not in a class, it's a function. And that matters a lot, actually. Methods also need what in order to operate? What does a method need? It might have parameters, but not necessarily. It needs an instance. It needs an instance of the class that it is a part of in order to function. So a method, in other words, I can't just call a method by itself. I have to call a method on an instance, right? I have to call a method on an instance. And so that is an important distinction between the two. Some languages take this idea of object-oriented programming so far that they say everything is an object. Everything. Doesn't matter what it is, it's an object. Java is a prime example of that, so we might see that in Unit 3 when we get there. C# is actually fairly similar in that regard. Python does not make that distinction. Python lets you do both kinds of programming, both procedural programming and object-oriented programming. So it's a lot more flexible in that regard. I don't have to use objects if I don't want to in Python. It's not necessary. In other languages, that's not true. I have to use objects. There's no avoiding it. There's no getting around it. It's a powerful, powerful tool, though, this idea of an object. And after a while, you'll start to look around at things and think about them as objects in the code sense, right? Just looking at your things around your house, you know, like your TV or your computer and thinking about what attributes it has and what behaviors it can perform. That's object-oriented programming. Object-oriented programming sees the entire world like that. What are the attributes that you have? What are the behaviors? What are the actions that you can perform? So can I use an object as a parameter into a function or a method? Is that allowed? Yeah. And what about an argument? Yeah, what's the difference? What's the difference between a parameter and an argument? We talked about this a while back.
What you put in there in the definition, an argument is what you give it to.
Parameters defined when I define the function, right? An argument is what I give to the function or the method when I actually call it, when I actually use it. So a parameter is a general value. Give me an integer here, right? Give me a string here. That's an example of a parameter, whereas an argument is more specific. Oh, you want an integer? I'm going to give you 7. That is the argument. Or I'm going to give you a string that says hello. That is the argument, right? Can I use an object as a return value? Yeah, for sure. I can use objects in all of those situations. And so think about what that means. When I create a class, when I give you a class definition, what I'm really creating in some sense is a type. I'm defining a new type. Just like we have ints and strings and booleans, right? Those types are all fantastic, but there's some limitations to those types, right? They can only do certain things. So this idea of creating a class is really saying, well, all right, I'm going to create a more complex type that I can use in my code. And then anywhere that I could use a type before, I can now use this object instead. So maybe I'm expecting an input parameter with the type of person, which is an object. That's fine. Or in the past, we've had limitations with our return values, right? I can only return one thing. I can only return one thing at a time. And so we saw recently how we can kind of get around that. We can return Maybe that one thing is a list. Maybe that one thing is a dictionary. It's actually got more values in it than just one, right? Now I have another way that we can return more than one value. I can put it in an object. Objects can have many different attributes. Okay? So I can create an object and return that instead. And this is going to become more and more the norm. I'm going to continue writing methods and functions that accept objects and give you back objects and manipulate objects in between instead of just passing around ints and strings. We're still going to use ints and strings. They're not going anywhere. But I'm going to use them as part of my objects instead of just having ints and strings floating around by themselves. So we're really taking this coding up a notch. What questions do you have? Yes?
So if you wanted to create a class that behaves, say, like a string that has like an additional method, we haven't covered inheritance, but can you create a class that inherits everything from string and add? Is that one?
Okay.
String plus class?
Sure. The question was, what if you wanted to make a class that behaves a lot like a string, but it does maybe one extra thing that strings can't currently do? Is that doable? And the answer is yeah, absolutely. You would use a concept called inheritance to pull this off. Is inheritance a topic for Thursday? I believe it might be. Yeah, I believe inheritance is a topic for Thursday. So yes, we do have a way of taking existing classes, existing objects, and adding things to them, which actually brings up another good point, right? String is an object as well. We've been treating it like a list of characters, but really it's an object. Strings are objects in Python. We haven't had to discuss that up until now, but it's true. Strings are objects. Great question. Any other questions? So if you're still feeling confused, I sympathize. This is a complicated topic. We're just getting started. Hopefully the walkthrough today will help solidify some of these concepts. So we're going to talk about basically all of this stuff again as we go through today's walkthrough. And hopefully that'll help you wrap your brain around what an object is and what it can do. So, all right, this is my cat. This is Franklin. He is a pain in the ass, but I love him to death. And so what I want to do with you today is design a class, design an object to represent cats. We're going to make a cat class. And then for Studio, we're going to give you some more ideas of objects that you can design and create. So today is all about creating different objects. So let's get started. I want to create a cat class. So I'm actually not going to use the book today. I'm going to switch over to the development environment that we had you set up as part of the homework assignments and do things in Visual Studio Code. All right? But I need your help to get started because I'm using LaunchCode's laptop here. I couldn't use my own laptop. So before class, I frantically installed everything on this laptop because it wasn't already on here. And so I'm basically starting from scratch. I have Python and VS Code installed. That already exists, but I don't have anything else. I don't have anything else. So I want to make a folder, a directory on here using the command line, using the terminal to hold my LaunchCode stuff. So how do I do that? mkdir, make directory, and then call it LC101. All right, cool. How do I then switch into that one? CD, all right, good. CD LC101. All right, I want to make a file to hold my code for today. So my code is about cats. How do I make a new file? Touch. And I'll give it a name. I'll call it cat.py. I did use a capital C there. That was intentional, right? Objects typically are going to be capitalized. Classes typically are going to be capitalized. That's one way that you can quickly distinguish between the two, between objects and non-objects. All right, and then how do I finally open this up in my code editor? Code cat.py. All right, cool. Here we are. The text is way too small. Yeah, okay. Oh, that's great. Those messages looked important. I did not read them. All right, I do want to make the text bigger. Let's see if I can figure out how to do that. Kind of. but also annoying. How do I make you go away? There we go. All right, cool. This is not doing exactly what I expected, but it's fine, I suppose. All right, so here we are. I have a file. We start writing some Python code, but you know me. You guys have been working with me for weeks now. I'm not just going to start writing code. No. I want to take some notes first. Let's document what we're trying to do. Today is all about designing objects. So I have to figure out what I want my object to contain. So what are the two categories of things again? Attributes and methods. Attributes and methods. Those things have relationships with the object. So remember, we're talking about cats. If I want to talk about attributes, there's a relationship that I expect between the object and its attributes. I'll even say this out loud, right? It's a has a relationship. So a person has a name. Person has a birthday. Person has a address. If you can say it out loud and it makes sense, then it seems like it's a good attribute. If you say it out loud and it doesn't make sense, then maybe it's not a good attribute, right? The person has, sleep, right? That doesn't make sense. That's not an attribute. So, let's write down some hasas. You guys are going to help me out here. Cat has a what? Fur color, like it? What else we got? Tail, okay. What else we got? Oh, getting deep. It has a voice, all right, so a meow, right? What else we got? Age. I'm sorry? Pattern, okay, yeah, sure. All right. A name, there we go. What else we got? A diet. Okay, sure. It makes sense. Cat has a diet, yeah. Yeah. What else we got? A speed? Interesting. Has an owner. Ah, I like that. Or does it? Yeah. A home? It has a what? I'm sorry?
Human.
A human? Maybe.
When you said owner, I thought you said voter.
Okay. I mean, they do. That's true as well, right?
Yeah.
Owner/human. These are all great.
Number of lives.
Number of lives. Okay. This is a great list. So we'll see how far we get with this list. And so what I would like to do next, right? So these has's become attributes. And so one thing that I like to do is I'm going to go back down this list and I'm going to decide, all right, this attribute is what? What kind of attribute is this? So if I look at fur color, for example, what type would you use to represent fur color? I'm sorry? A string. Okay. What would you use to represent a tail? Could be a Boolean. Oh, I like that. Does it have one or not, right? Personality. Oh. It's a tricky, right? You could say string, so it's like grumpy or happy or cuddly. Although I think cats have, or that's a little too simplistic to describe feline personalities, but meow. That's a string. What does the cat say? Age would be int, all right. Pattern, this is tricky. String, right? I don't know. Name is a string. Diet, ooh, that's string. It's getting a little repetitive here. Speed, integer. So what would the units be? Like miles per hour? Or, I mean, are we talking average speed? Because sometimes its speed is 0, actually a lot of the time. And then other times, like at 3 o'clock in the morning, its speed is like 100. Yeah, do you have a question in the back? Yeah, there we go. I like this. Could it be a list of strings? Could it be? Yes. Yes, it could. A list of all the things that your cat is willing to eat. For my cats, that list would be very short. They are very picky. For other people's cats, I suppose it would be a lot longer. My cats have a very limited diet. But okay, well, let's take that a step farther. So I look at this pattern, right? And string is like, it kind of works. Saying it's a calico or a tabby or whatever, it feels a little inadequate to me. It could be a dictionary, or could it be an object? Could it be another object? Maybe we're not going to do this. We're not going to have time today. But maybe I can make a pattern class, right? That has more detailed information about what that pattern is. And then I could use that pattern class here as the type of this attribute. Think about what that means. I would have an object within an object. That's okay. I can do that. Again, remember, anywhere that I have a type, I could swap this out for an object instead. So we're not going to get there that far today, but I just want to plant that seed in your mind because it is something that you're going to see. It is something that we are going to do eventually. So speed, could be a dictionary, right? I could have an entry for stationary, an entry for walking, an entry for the midnight zoomies, and all of those things. So with the dictionary, I've got a little bit more that I need to specify though, right? Dictionary, I usually want to specify the types of the keys and the values as well. So I'd say, like dictionary of string, I don't know, double or float, right? How precise do we want to get with our cat speeds? I don't know. Odor, ooh. I don't know, string. Could be a list. You could make an argument. Owner, human, that's probably, so again, this could be like a person class. If I have a person class, I could use that here. Or maybe I don't care about the birth date of their owner. Maybe I just care about who the owner is. So you could also, I think, make an argument to just have this be a string, right? The person's name. Who owns the cat? Or stray, if it's just wandering the streets. Same thing for home, Could use a string, or you could make a more complex thing there. For number of lives, though, I think probably an int would be sufficient. All right. So again, not a comprehensive list, and we're also not going to have time to do everything on this list today, but we'll do at least some of the stuff that's on here, for sure. Right? So let's move on. The other category is the methods or behaviors. Actually, real quick, before I go on to behaviors, notice one thing about these attributes. If I had to categorize these in English as parts of speech, they're all, what part of speech? They're all nouns. They're all nouns. If I'm coming up with something that's not a noun, it's probably not a good fit, and it's not going to sound right. Cat has a jump. Oh, well, okay, that's a verb, right? It's more of a verb than a noun. Actually, jump I think could go either way, but still, you get the idea. It's not going to fit when you say that sentence out loud if I have something that's not a noun there. So these really should be nouns. And so behaviors then, what parts of speech am I expecting down here? Verbs, they're actions, right? And so the relationship that I might say is can or can do. So people can eat, and so can cats. I should write that down. Right? What else can cats do? They can hunt, all right. What else we got? Sleep. What else? Wake you up. Make noise. All right. Kind of the same thing, right? They can meow. Well, wait a second. Hold on. I had meow up here already, but meow is both, right? The act of meowing versus what a cat actually sounds like when it does meow. It can be both. That's okay. I like it though. All right, what else we got? Play, all right. Have the zoomies so they can run. They can move.
Climb in the box.
Okay. Use the litter box. Oh, that's not what you meant?
No, that's why that works too.
I mean, yeah. What else we got? Terra furniture, so they can scratch. Notice I'm trying to generalize these things, right? Terra furniture, yes, but they can scratch whatever the heck they want. It just happens to be your couch most of the time. Or, yeah, or yourself, or other cats, right? What else? They can what? They can trip you. So how would we represent that? I think that has more to do with where cats move. So, you know, maybe instead of run, I'd say move, their position. I mean, I guess the question that I'm trying to get at, and this might be a little controversial, right? Do you think your cat is like looking at you from across the room and then running over and trying to trip you, like actively? Or do you think that it just happens to be in a spot and then you walk past it and fall over your cat? Yeah, I don't know. Controversial, I suppose. I'm sorry? So that has to do with personality, right? So they have moods. Cats have moods, but that's more of a hazza, right? Cat has a mood. They can purr, sure.
Someone has a question.
I'm sorry. Yeah, what's up?
To the trip thing, can you call a method in an object that affects the attributes of another object?
Yes. The question was, can you call a method an object that affects the attributes of another object? The answer is yes. Absolutely, you can. Yes. I'm trying to think if we'll see an example of that today. The answer is maybe. You guys have a lot of control over where we go with this exercise, so we might see an example of that today, or we may not, depending on how much time we have. But we will definitely see that eventually. Yes, objects can affect other objects. Absolutely. I'm looking at number of lives here and thinking there's a behavior, right? Oh, that's sad. Whoops. All right. That's enough behaviors. So if I look at this list of behaviors, I'm going to do a similar thing that I did with my list of attributes, but it's a little bit different this time. Instead of thinking about what the types of these behaviors should be, I'm thinking about the types of what? Parameters, both input and output, right? Is this going to return something? If so, what's that thing going to be? Do I need to take in a parameter in order for this to happen? In order for this to work, right? So if I look at this one, eat, what might the input parameter be? Food and water. So those could be complex types of their own, right? I could have a food class and a water class, right? Or maybe you consider water to be part of the food class. I don't know. It's your program. You get to make these kinds of decisions, right? So maybe the input is some kind of a food. And then the return type could be what? Do we need one? We don't need one. We don't need one, right? Hunting could be, again, I'm hunting food. And the return type here could be how many I found, or was I successful? Right? Did I catch the thing or did I not catch the thing? Right? So to me, that's like a Boolean. The output's a Boolean, the input is some kind of a food. Sleep. What might an input here be? Some time, right? So int could work here. Just some representation of quantity. Output, I'm not sure it necessarily needs one, right? A meow, does this need anything? I don't think it does. And so you could be like, well, what does your cat want to say? But we actually sort of already covered that, right? It's covered up here. And so then your counter-argument might be like, well, cats say different things at different times, and that's true. Maybe this should be a list. I don't know. That's certainly an argument you can make. But I don't think it needs an input or an output. Playing, any ideas for inputs / outputs? Toy. All right, cool. Move. Move. So where does it want to go, right? Where does it want to go? So we could represent that as, like X, Y, Z coordinates, 3D spatial coordinates if we wanted to. Or we could have a location class that represents a particular spot in the world, possibly, right? It doesn't, it could go either way. Int, or I guess it'd be floats probably for positioning in 3-dimensional space. All right, I'm gonna skip that one. Scratch. So input might be, I'm sorry? The thing that's being scratched, all right? So that could be a string, right? And then the out, I could have another input here too, right? Like how many times do I want to scratch that thing? Just sit there, go for it. Purring, do we need any inputs? No, I don't think so. I don't think we need any for that one either, right? Just happens. Just happens. Lives left? Well, I think, so again, number of lives we have as an attribute up here. And so one thing that we'll talk about when we actually do this is I can actually ask you, what's the value of that thing, right? How many lives you got left? I can always ask you that question. Was there a question in the back? Yeah.
So it seems like methods do two things. They either do an action or a verb, or they ask about what the current state of an action is.
Sure.
So is it safe? And I'm looking at your method list, and as we were trying to decide if these methods certain parameters, if we need to define parameters, it almost seems like if a method is simply checking the state of an attribute, and perhaps it doesn't need parameters defined. Is that a fair?
So the question was, how do we know if we need parameters here or not? Is it based on what the method's actually doing? And you're right, sometimes it's just using or changing existing parameters, right? Examining existing parameters, which itself is a verb. I should point out that's also a verb. Asking for a particular value or using a particular value is also an action, a behavior. Others are more complex. So moving, when I think about moving a cat to a certain position, that's going to update. We don't have a position here, right? But that sort of implies that we would need one in order for that method to work. And this is how design works too, by the way. I don't just sit down and crank out a list of hasas and a list of behaviors and say, all right, we're good. No, it's constant back and forth, constant revision, like, oh, I forgot this one, or I thought I needed this one, but it actually sounds like it's not very useful or unnecessary, so I'm going to take it off the list. So, this list is never set in stone. So, position could be float, float, float. Position X, position Y, position Z, right? To represent a position. Or you could have a location class like we talked about. And so, yes, you're right. When I take in parameters here, likely that's probably going to modify either these attributes or the attributes of some other object, although not necessarily. It's certainly not required that happens. We'll see some examples of both when we actually code this up. Methods that modify the attributes of our cat and methods that don't modify the attributes of our cat. All right, so we don't have time to do all these. In fact, I'm already at risk of running over time today. So I'm going to go ahead and pick a few things for us to implement. I'll do the meow. I'm just going to put stars next to them so that I remember which ones I want to look at. I'll do the meow, and we can do the name for sure. We can do what? I'm just going to pick a few for the sake of time. We could do color, sure. I think we're good though after that. That's enough for today. Again, so I'm making a version of a cat, and I know you guys are watching as I go through this, but you have an opportunity here to make your own version of what a cat represents to you, right? The way you design your cat object does not have to be the way I design my cat object. What do what are we using this cat object for? And right now we're just doing it for the heck of it. But ultimately what I would want to think about is, okay, of these things that I've listed, which ones help me solve the problem that I'm trying to solve? Which one of these help me construct the program that I want to construct? And your answer to those questions might be different than my answer to those questions. And that's fine. That's design. Design is a lot more creative, a lot more artistic of a process. So, I don't expect your things to look like my things necessarily. And if you don't like the ones that I've chosen, you're welcome to add some additional attributes and behaviors based on your own personal preferences. So we'll do a couple behaviors here. I'm just going to do, we did the number of lives thing, so we can do this one, and then, okay, we're good. I think we're just going to do a few, again, for the sake of time. And so now I'm ready to start writing some code. I put a lot of stuff here, and now I'm ready to start making some code. So let's do that. How do I create a class? Class. Cat. That's the name of the class that I want to create, right? Anything else? Colon. Good. What am I going to do first? Where's a good place to start? Constructor. Constructor is a good place to start. When I look at a class, if I'm looking at a class definition, I want to see that constructor right up top. Every time. That's where it belongs. Because your class doesn't do me any good if I don't know how to create it. If I don't know how to make new instances. It doesn't do me any good. So I want to see that right up top. So how do I do that again? Define underscore underscore, and you can see VS Code's trying to help me out here, right? Define init. And now I have to decide what are the parameters. So what's the role of a constructor again? Before we decide on parameters, what's the role of the constructor again? Create an instance. It has one job though, right? How do I create that instance? It's got one job. I'm sorry? It's input? Template. What's the job of the constructor? Constructor is responsible for one thing. Initialize the attributes. That's its job. Initialize the attributes. So for the attributes that I've selected, I think I've got like 4 of them, right? For these 4 attributes, I want all 4 of those attributes to have a value by the time this constructor is done. Does that make sense? I don't want to leave any of them off. All 4 of those need to have a value by the time this constructor is finished. That's it. That's the only thing I expect this constructor to do. So the question then is, all right, what am I setting those values to? Where do I get the information to set those values? There's actually two places. One is what we're looking at right now. I can accept them as inputs to my object, right? So I could say color. Oops. Color, right? And then, so you have to, if you want to make a cat, you have to tell me what color that cat is. That's what I'm telling you, right? You have to tell me what color that cat is. If you want to make a cat, you have to tell me what the name of that cat is and what its meow sounds like. That's 3 of the 4. The 4th one, I'm going to argue, actually does not need to be a parameter. Why not? Cats always start with the same number of lives, right? That's what they say. Right? It's always 9. If I create a new cat, how many lives is it going to have? 9. I don't need that as a parameter. I know what the value is. I can just set it. I can just say what that value is, so I'm not going to include it. Did I see a question somewhere? Yeah.
So you are creating a parameter for the individual, for the constructor method.
Mm-hmm.
You call that constructor, you explicitly have to pass in what the color is.
Yes.
What the name is, and what the cat is saying.
Yes, that's correct. When I call this constructor, when I want to create a new instance of a cat, which we will do, I have to specify what these 3 values are. So what do I do with these values now? That's another question? Yeah. So, I'm sorry, I couldn't quite hear you at the end there. Were you suggesting I do like this? I'm not sure I follow. Put it where exactly? Like here? Well, so I was just asking what should go in here, right? This is what I'm asking now. What should I type in the constructor in order to satisfy its one job? So do you have an idea about that? Does anybody have an idea about that? Yeah. Ah, does self have to be one of the parameters? I was waiting for somebody to talk to me about this. Does self have to be one of the parameters? Yes, all the time. And this is something that can help you distinguish between whether we're talking about a function or a method, right? A function or a method. When I see self there in the list of parameters, again, remember, self refers to an instance of this object. And if we want to get more specific about it, right? Self is the object that we are currently working on. Self is the object that we are currently working on. Self is the object that this method is being called on. Do I know exactly what object that is? Do I know if it's my cat or your cat or somebody else's cat? No. But I'm going to write code in such a way that it will work for all of those cats, whether it's my cat or your cat or somebody else's cat. That's the idea behind using this self value. And so now that we've got that included, we can talk about what needs to happen in the constructor. What do I need to do in the constructor in order for it to satisfy its job? I got to initialize all the values that I expect to see here. So it's the 3 from the parameter list plus that other one that we said we knew the value of. And so here we'll see self in action, right? That's how I can set the color parameter. I can do the same thing for name and meow. And think about what this means. When I say self.color, that's referring to the attribute of the object, whereas this color is the parameter that's being passed into the constructor, right? Or if it helps you make the distinction clear, you don't have to call them the same thing. Maybe it's easy to see and understand what's going on if you don't call them the same thing, right? Fur color, cat name, I don't know. You can call them something different. That's okay. They don't have to be the same as the parameters that are coming in. And so then if I wanted to do one for the number of lives, I could say self dot
Lives equals 9.
lives equals 9. I don't have a parameter for this because I just decided that all cats are going to start with 9, right? Are there any questions about that? Our constructor is doing its job. I said I wanted 4 attributes. I see one line of code setting each one of those 4 attributes. It's doing its job the way that we expect it to. The role of the constructor is to make sure all of my attributes have some value by the time it's finished. And we have succeeded. Okay? So then, once that's done, we can look at our behaviors and start implementing those. I only highlighted 2. Maybe I should have done some more, I don't know. Maybe if we have some time, I can do some additional ones. So I'll do meow first. So if a cat wants to meow, what is it really doing? It's just going to probably just print out a statement with whatever the cat's distinctive voice is, right? But we could actually take this a step farther. Let's say the name of the cat as well. So the name of the cat says whatever that cat wants to say. Does that make sense? So I want to be clear here, right? I could put in a statement, a print statement that has, you know, Franklin. That's the name of my cat. And that might work for some of the cats that I'm planning to deal with. I'm sure I'm not the only person in the world that has a cat named Franklin. I'm sure there are others. But there are plenty of other cats in the world who are not named Franklin. And this statement's going to fail them when I try to do that. So what's a better way? Self.name. I want to get the name of this cat, the cat that this method was called on. I don't know what cat this method was called on, right? I have no idea. Could be my cat Franklin, could be your cat, could be somebody else's cat. But whatever cat it is, I want to get that cat's name. So I'm going to say self.name. It's going to look at this object, this cat object, grab the name, whatever it is, and substitute it in. And so in order to make this happen, I skipped another thing again. I gotta put self here, right? I gotta put self as a parameter in here. All right, and so now we can piece together the rest. The name of the cat says, and then I want to insert the meow here as well, right? How do I do that? Self.meow. There we go. It's a pretty simple statement. Should it be, oh, cat meow, you're right, I forgot I changed the name of that, thank you. Thank you. I forgot that I changed that. And so we actually have enough code where we can try and do a little test of this real quick, which is what I want to do. I'm going to come down here after my class and create a main method. And I want to create some cats. I want to create some instances of my cat class. So how do I do that? Let's make Franklin, my cat, my orange cat at home. How do I make a cat? I gotta call the constructor. So how do I call the constructor? Do I just do init? No. It's the name of the class. It's the name of the class. All right, and now you can see it's helping me out here. I have to specify what those parameters are. Notice self is not included. I don't have to specify what self is. Self is the instance, whatever the instance happens to be. So that's already taken care of for me, but I do have to specify the color. He's orange. I have to specify the name. His name is Franklin. And I have to specify his meow, which is probably something like this. He's not a very shy cat. Oh, but wait a second, I have another cat. Her name's Sally. So let's make her too. Okay, Sally. Sally is, I guess I'll call her brown. That's not entirely accurate, but it's good enough. Her name is Sally. And her meow is probably more like this. Sally is shy. Sally hides in the closet all day, sneaks out twice a day to eat. That's about it. All right. So I have these two cat objects. If I were to run this program right now, what would happen? Nothing. Why not? I made two cats, but I didn't make them do anything, right? I didn't actually have these cats do anything. So there's not really much for me to have my cats do right now besides meow, but I can at least give that a try, right? So let's do that. Let's make Franklin meow. And let's make Sally meow. So notice, instance name dot method that I want to call on that instance. What happens when I do this? This instance, whatever is to the left side of the dot, that becomes self. That becomes self. And so then when it reads this self.catName, it's going to look at Franklin and pull out whatever I gave as the name for him, which is Franklin. And then when I do this again for Sally, it's going to look at whatever Sally's cat name is listed as, and pull out the word Sally. Does that make sense? Self is just whatever instance I have listed on the left-hand side here when I call a method on that object. All right, let's try to run this and see what happens. I'm gonna go back to my terminal here. You guys, I was gonna have it blow up, but you guys aren't gonna let me do it. That's all right. You're saying I need to do if main. Oh, it already knows. Oops. Well, that's fine. You guys are on it. All right, now I can try it, right? Come back over here to my terminal, and if I want to run this, I should just be able to do what now? Python cat.py. And if I didn't screw anything up when I installed stuff before class, uh-oh. Did I not save it? What did I do? I didn't save it. Okay, thanks. Got it. Let's try it again. Oh, by the way, while we're on the topic of command line, the up and down arrows are like your best friends. You can scroll back through all the previous commands that you've run. Don't type the same command more than once, please. Just hit up and down. Here's another little tip. This file name's not too long. Cat.py, it's like 6 characters. It's not too bad. But let's say I had a lot of file names or some long file names and I don't want to type them in because I'm worried if I'm going to get one of those letters incorrect, right? So I can type the first letter or 2, hit the tab key. It'll search all the files that are in the folder that you're currently in and find whatever matches and put it there. If multiple ones match, like if I had 2 files that started with a capital C, it'll show me both names. I have to type another letter in and then hit tab again, and it will fill out the name for me for autocomplete. Those 2 hacks, the up and down keys and the tab key, will save you hours of your life at the command line. They're so useful. So that tangent is very much worth it. All right, let's try it. Franklin says, meow. That's not accurate. It's more like, meow. And Sally says, meow. It worked. It worked. Any questions? Yeah, what's up?
The 2 constructors.
Uh-huh.
When you were saying you can do that, are you talking about overloading or
I can have 2 constructors. I can create another method called init.
any different parameters?
Different parameters. That's the catch. I can't make one that looks exactly the same as this one. It has to be more or fewer parameters than the other one. Yeah. Was there another question over here? Yeah.
I was messing around with a different class, but I have a question from this. So if you did like the initialization, like what's one of the cat's name? Franklin. Franklin dot meow, and it will return what meow it is. But I did something where I called the class dot method, and in the argument of the method, I put the name of one of the initializations. What's the difference? Because it gave me the same output.
I'm not sure I understand what you're saying.
For example, so you put Sally.meow.
Uh-huh.
What would happen if you put cat.meow, but in the argument of meow, you put Sally? Because when I tried it, it's different.
No?
It gave me the same output. But it's a different. I don't know.
Okay. So this is referring to the class, right? And then this is the meow method. And then you're basically telling it what you want self to be. I can see how this would get you to the same place, but I think it's...
Would it reinitialize that?
No, Sally already exists, right? So I still have that instance. Sally still exists. I actually have to say I'm not super familiar with the syntax. Let me just run it and verify. Yeah, it still works. It's like a static method, that's right. We're calling it like a static method here. So when you see the class name out in front, that means it's a static method. I'm actually a little surprised that this syntax works. I certainly wouldn't recommend it because the way object-oriented programming traditionally works, conventionally, is instance name first, and cat is not an instance of the cat class, right? Cat is the cat class, so it's not an instance. So instance name first, dot, method that you want to apply to that instance. So that's interesting that it does work that way. I've never seen it. I am going to stick with this way, for sure. Let's see, I guess I'm already a little bit over my time, but I want to do like a couple things just to wrap up today. I wish I had more time because it's such a great topic, but let's make a string method real quick. So remember that was underscore underscore str. Do I still need to do this self business? Yeah, you sure do. You sure do, because now I'm deciding, all right, which attributes here are important enough to be printed out, right? You might say all of them, and that's fine. You can do all of them if you want. Or you might say, well, I don't care what colors the cat are, right? Just tell me the name and the meow. Or I don't care what the meow is, just tell me the name and the color, right? That's fine too. But you need to make a decision, and then we're actually going to return a string here. So, and the way that I would typically format this, it's usually pretty consistent. I would say something like, the name of the attribute followed by the actual value, self.catName, right? Plus color, I guess we'll do. Plus self.cat. What did I call it? Fur color, thank you. And you might stop there. You might say that those two things are okay. Usually, so what do you want to put here? Usually you want to put enough information that I can tell which cat is which, right? So if name and color is enough for you to distinguish between your various types of cats that you expect to have, then that's fine. It gets a little hairy because, there could theoretically be lots of orange cats named Franklin in the world, right? That's possible. That is a possibility. But just for the sake of showing how this works, I'll leave it at that for now. And then what this allows me to do is, something like this, print Franklin. Oops. I can just print an instance. And so what happens when I print an instance? It's going to look to see if this method exists. And if it does, it's going to print this. It's going to print this stuff that I told it to. And if it doesn't, it prints the memory location, which is not particularly useful to us, but it's something. And so I can save this again and show you. Scroll back over. Name Franklin, color orange. Hey, cool, it worked. Let's put the number of lives on there too, I guess, because the last thing I want to do before I take up too much of your time is I want to make one more method that actually changes one of the attributes. That's the last thing I want to do. So I'll say lives plus self.lives. Okay. And let's just save that and try it again. Oops, all right, I made a mistake. What did I do wrong? Did anybody see it?
It's an integer. You have to make it a string.
It says invalid syntax. I forgot the plus sign here. I forgot the concatenation. Let's see if that fixes it or if I have more problems. Oh, now I have the other problem that was mentioned. Can only concatenate string, not int. So I can't, but that's an easy fix, right? Stick str around that guy. All right, one more time. Cool, it works. Name Franklin, color is orange, lives is 9. All right, cool. Let's change this. We said that cats have 9 lives. They don't always start that way, right? So let's, whoops. So let's make come on now. How do these things work? Let's make a method that's going to affect the number of lives that a cat has. I want the number of lives to go down by 1, right? But wait a second, we need to be a little careful. Can a cat have negative lives? No, so I only want it to go down by 1. if it's greater than 0, right? So if what? Self.lives, there we go, greater than 0, then how do I make it go down 1? Self.lives equals minus 1, or minus, or however you want to get there. Minus equals should work, yeah. Should work. And so let's give it a try. They all start with 9. We actually saw that when I was looking at the string output a minute ago. That's why I put it on there, because I wanted to see if the values would actually update appropriately. And so I can say Franklin, and he should have 8 lives now, right? Or I can do it a couple times if I want to, right? And then print Franklin. And then 2, just for comparison's sake, I can also print out Sally, right? Because Sally's lives should remain unchanged. That's something that we also want to be aware of. Make sure that I'm not affecting other objects. So let's give it a go. I put it in here twice, so Franklin should be down to 7. Let's give it a go. Where's my terminal? All right, there's the before. Goes down by 2, and you see it's 7 now. But Sally has remained unchanged, which is actually how it would work in real life. Sally's very cautious. By very cautious, I mean she never leaves the closet. Whereas Franklin, you know, if he sees a fly on the lamp, it doesn't matter. He's going to knock the lamp over. That's just the kind of cat that he is. If he sees an open door, he's going to go through it. And then he's going to regret it and turn around and start crying. That's just the kind of cat that he is. There's a lot more that we could do with objects, and you all will be working with objects as part of the studio today. It's going to be more of this. Some of the things that I wish we'd had time for, but we didn't quite get to, I can make objects in these methods if I want to. So one thing, you know, cats can multiply, right? That's another behavior that cats have. I could have cats get together and make more cats. That is totally a thing we could represent in the code. I could make more cats as part of one of these methods. Right? That's totally okay. I can do that. That's something that I think you might need to use on your studio today, is one example. Yeah, sure. I'll post this online too as soon as I get off the stage. Any final questions, actually? I think I'm going to stop here just for the sake of time, but any final questions before I get out of your way? Yeah?
Why was it Franklin.meow instead of Franklin.catmeow?
Okay, good question. Franklin.meow instead of Franklin.catmeow. So, catmeow is the name of the attribute, right? Whereas Franklin.meow, that's the name of the behavior. So I'm always going to call a behavior a function on an object. In other words, I'm not going to access the attribute directly. I'm going to call a method. I'm going to call a method on that object, which may access that, which may access an attribute. And so, you know, one other thing I could do, I know I said I was done, but I lied. I could do something like this: get number of lives. Return self.lives. Perfect. And so now I have a method that's going to tell me, it's not just going to print it to the screen, it's going to give me the actual number, and then I can do other things with that number if I want to. So I can say something like lives equals Franklin.get number of lives. So it's accessing the attribute, but doing so a little bit indirectly, right? It's doing it through a method. It's letting the method access that value and then return it to me, which I am then storing in a variable. Any other questions? Great questions. This is a massive topic. I really wish we had more time to talk about it, but unfortunately we don't. At least not right now. We'll talk about it more on Thursday. Any other questions right now? All right. Oh, yep. What's up? I'm sorry? Can you access attributes of cat in the main function? Franklin.lives or Franklin.catName? Let's try it and see. Yep, sure can. But, follow-up question to your question, should you? And I'm going to say the answer is no. I'm going to say the answer is no, you should not do this. You should not do this. Let the attributes stay internal to the object. If you want to manipulate the attributes, create behaviors that will manipulate those attributes for you. There's a good reason for that. There's a good reason for that. I may not want every single attribute to be exposed to the outside world. If I'm thinking about a person class, right? I don't want my social security number exposed to the outside world or other people's social security numbers exposed to the outside world. I want those to be internal to me. And then if I decide that I need to provide that information for whatever reason, I can have a very controlled way of accessing it. So it has more to do for security than anything else. But even just good design states that we should access attributes via behaviors, methods, not directly. Not directly. Other languages won't let you do that, and Python is a little bit more flexible. But even though it will, it doesn't mean that you should. End rant for now. More to come later. I think for now, though, I'm going to get off the stage, let you get started on Studio. Studio is going to have you do more of the same, design some objects. I'm not going to have time to go over all of them at 8 o'clock, so if you're working on one and you really want to see an answer to it or talk about it, think about it, because I'm going to ask you which one you want to see at 8 o'clock. We'll do whichever one you guys want. Thanks for your help today.